afternoon. Hi, the project that I'm going to be talking about today is a little project that we started last year with some funding through the Tamarisk Coalition from Xcel Energy and from the Colorado Water Conservation Board. And we kind of got this together quite quickly last summer because we realized our window of opportunity to get some of our surveying done before some of the removal work was accomplished. We had a pretty tight window. But what's funny is in the end, the removal hasn't been accomplished yet, and it's probably not going to happen until next fall. So we actually now have another summer of surveying possibility for this summer. So also wanted to mention that this is a work in progress, so I don't really have any final results yet at this point. But I just want to share with you what we're doing and also to hear if anyone has suggestions or ideas for how we can move forward with it. So we've known for many years that Tamarisk in riparian areas has a stabilizing effect on river systems, beginning with Wilgraph's work back in the 70s, showing Tamarisk moving up the Green River and the Colorado River. The high stem density on the floodplains provides a stabilizing effect, reduces the flow energy, causes deposition, and we see channels shifting towards a narrower, more stable condition. And as we've seen through this conference, there are a lot of efforts now to remove Tamarisk and restore our riparian areas. And so a big question is arising, is as we remove vegetation, what sort of destabilizing effect might that removal have on our river systems? And so some work that's already been done, there was a study down on the Rio Puerto in New Mexico where they sprayed a 12-kilometer reach. This was helicopter spraying, so it sprayed all of the vegetation, including the natives. It was sprayed in 2003. They had a 30-year, I think, recurrence interval flood in 2006. And the results, so this is on the x-axis here, we have distance downstream. The gray region is the part of the river where the spraying happened on the Rio Puerto. So you can see the fraction of bank eroded was much higher in the sprayed region. The cross-sectional area increased in the sprayed region. The average channel width increased in the sprayed region, and they saw erosion in the sprayed reach and then deposition downstream. And so this was a clear demonstration of the destabilization of vegetation removal. But like I said, in this case, they sprayed also the natives, and this was an overbank flood, so the overbank flood was able to clear away all the dead wood from in the sprayed removal area. Other studies have not been quite so conclusive in the destabilizing nature of removing vegetation. Ellen Wall at CSU has been involved in some work down in Canyon de Chelly, and their initial modeling efforts suggested that there would be quite a bit of channel erosion and destabilization following Tamarisk removal. But their actual field study, where they looked at 4 sites, and in this case they actually looked at the removal method. They had a control site, a cut stump, and a whole plant removal. They really didn't see big differences between the removal sites and the non-removal sites. Now, there were some confounding factors. One, they didn't have any really major floods in that time period. There's also an extensive clay layer at the toe of the banks, and they did leave the native vegetation in this case as well. So the question is, as we remove Tamarisk, what sort of geomorphic impacts are we going to expect, and how can we best monitor and measure the changes? So here in the Grand Valley, along the Colorado River, we have quite a bit of Tamarisk. This is the reach that we've studied here. That's a 51-kilometer reach from Palisade down to Loma. This orange area is showing the area where Tamarisk has been mapped to be present based on it was a 2005 mapping effort done by the Tamarisk Coalition. And it totals to about 2,700 acres in the Grand Valley. And then if we isolate out where Tamarisk is thickest, where we have 50% or greater density of coverage of Tamarisk in the Grand Valley, it's about 1,200 acres. So these are the green polygons along the Colorado River here. And over the last few years, well, actually beginning in the 90s, but more intensely in about the last 8 years, we've seen a lot of effort towards removing both Tamarisk and Russian olive. And the Tamarisk Coalition is undergoing an effort right now to create some GIS coverages with polygons that indicate areas where Tamarisk and Russian olive removal have been accomplished. So Shannon Hatch with the Tamarisk Coalition, working with Ben Bloodworth and myself and with Alex Acey, one of our geology students, have been looking at, or trying to create these shapefiles where we indicate areas where removal has been accomplished, what year, what method, what agency, what sort of treatments, have they been retreated, going through trying to document all of that and putting it together in GIS layers. So this is what we have so far. This is removal that's been done by the Audubon Society, City of Grand Junction, Clifton Sanitation District, Mesa County, NRCS, and Colorado Parks and Wildlife have done quite a bit. So this is what was been removed since the 90s up through 2013. It's about 175 acres. There's probably another 50 to 100 acres slated for removal in the next year. So what we're interested in now is then saying, okay, so now we've seen there's been this work for Tamarisk removal along the river. What sort of geomorphic impacts are we seeing? And I just want to show you a quick little example that sort of highlights the complexity of the challenge in looking at how river channels change and what sort of things are going to affect whether they do and whether they don't. And one of the sites that I visit quite often with my students is this nice meander bend right here. Here we are at Colorado Mesa, and this is the Colorado River flowing from the bottom right to the top left. And there's this meander bend here at the Redlands boat ramp. And the blue outline is the digitized channel from the topo map, which is from 1973. I love to use this as an example for students and how you can't trust that a river is always going to be in the same place on a map, and thinking about the fact that these topo maps that we use are not necessarily recent. So from 1973 to 2001, which is when this infrared aerial was taken, the channel migrated about 200 meters at this meander bend. Interesting note, this road, Redlands Parkway here, was under construction during the 1983-84 floods. And so this is a big fill section of road. So it was like a peninsula in a lake at that time, because this was all completely inundated during those floods. And speaking of the 83 floods, I'm going to put a plug in for a water center event that's coming up in April. We have Kevin Fedarko, who's the author of the book The Emerald Mile, which is a great story of the 1983 floods in the Grand Canyon. He's going to be here on April 17th, which is a Thursday night, talking about his book. So if you're going to be in Grand Junction at that time, that'll be a fun event. So back to this meander. So we have 200 meters of migration from 1973 to 2001, and this bank is lined with Tamarisk. So here's looking upstream on the right bank, Tamarisk in 2002. In, I think, 2005, the Tamarisk were removed along that bank. And so this would be a site where we would say, oh, wow, what's going to happen? Is this bank going to destabilize? So here's now this same bank line looking downstream in 2011. So you can see the how the Tamarisk have been removed. And just, going through Google Earth's historic images, here's 2003. So you can see the Tamarisk along the bank and how close the river is to Redlands Parkway now. 2006. And 2011. So we haven't seen much change. In the 90s, after the 95 flood on the river, the city went in and dumped a bunch of rock in piles, these rock veins on the bank. And then they also did some really sophisticated engineering work where they cable tied together power poles and anchored them to the bank to try to protect the bank between the rock veins. Which it's really interesting to go out there during high flows, because wood floats, right? So during high flows, these become big rafts of power poles along the bank. So it's been fascinating to watch the progression along this bank line, even when we have high flows and with Tamarisk removal, because their bank protection measures have actually been quite successful. We saw there was a big chunk taken out of the bank over here and loss of the bike path in this area, but for the most part, this bank line has been quite stable. So not what we would have expected, from Tamarisk removal. So the purpose of this study was to try to first establish some methods for how do we monitor and measure geomorphic adjustment following vegetation removal, and then also to look at this one reach, this 51-kilometer reach, by doing some field surveying and also by doing some GIS analysis where we're overlaying historic aerial photos and measuring how the channel has changed pre-removal and post-removal. And then some questions that are coming up is, how does the removal method affect whether the channel changes or not? And is the beetle playing any role and having any effect? And those are, we're not really sure how we're going to answer those, but those are some of the things we're thinking about as we look at this. So the first part was the field study. We had 2 field study sites, Franklin Island, which is at 32 Road here, and Walker State Wildlife Area. They're both Colorado Parks and Wildlife properties. And they were planned to have Tamarisk Russian olive removal done this fall, or sorry, last fall of 2013. That didn't happen. It's probably going to happen fall of 2014. But we did get out in the field and get our baseline survey done last summer. So what we did at Franklin Island, we were actually really fortunate to have some survey data from Parks and Wildlife from some work they did back in the late 90s. They did a really extensive survey of this reach in 1999 as part of a 2D fish modeling project, or 2D flow modeling for fish habitat. And they were out with a boat with an acoustic Doppler current profiler, a sonar, and a survey grade RTK GPS on their boat. And they surveyed, they just zigzagged back and forth down the reach, surveyed the bathymetry, and then walked the bank lines at low flow and got great topography on the banks with the RTK GPS. And then they drew 58 cross-sections across the river and extracted those cross-sections out of their TIN, their digital elevation model from their survey. So what we did then is established, we didn't have the luxury of being able to spend that much time out there and redoing that survey, but we established 6 cross-sections that overlap with their existing cross-sections. And they were surveyed with GPS that uses Mesa County's real-time virtual network. So it's survey-grade GPS. And we relocated their endpoints and then resurveyed those cross-sections. We ended up out there during really low flows in August, so our plan to use a boat with a motor didn't work out, so we were in duckies and waiting, and it was really quite an adventure. The other piece that you can see, we extended the cross-sections all the way across Franklin Island. There's a side channel over here. Our plan is to resurvey, or to survey that part of the cross-section after they've done the clearing, because the Tamarisk is so thick, you can't get through at all. So we thought we would get out there as soon as they did the clearing. And with our work with the Mesa County Survey Office, who provided us with the GPS equipment, they have a new LIDAR drone and they've agreed to fly the island for us, for our topography. So that's going to be another fun piece of this adventure, is seeing how we're going to incorporate that data with our existing data and make this all work together. So some interesting things we saw is that in this portion of the channel, we actually had erosion on the right bank, about 20 to 30 feet. So their endpoints were actually out in the river when we resurveyed. And then further down at this end of the reach, there's deposition on the right bank. And it's interesting, if you look at the aerial photos, you can see the side channel, the deposit from that side channel sort of ebbs and flows, and we have just hit it at a time where there's a big deposit at the mouth of that side channel. So we can already, see some of the channel change that's occurring there in the pre-removal condition. Our other site was down at Walker State Wildlife Area. As far as I know, there hasn't been any surveying effort done down there. So we established 4 new cross sections. So we've got our baseline data. They're planning to remove all of the Tamarisk on this whole point bar later this year. So it'll be interesting to see what happens there. So the other piece is we've done some GIS analysis. Tetra Tech did some work for the Tamarisk Coalition where they digitized the center line and the water surface from 1937 aerial photos and 2007, which is really nice. It gives you a great idea of some of the really dramatic changes that have occurred in the channel. But because they surveyed the water surface, that really doesn't help us see what's going on with the banks. And there's also been a lot of removal done since 2007. So our current work, this is explained on Alex Acey's poster. If you had a chance to visit it in the poster session, he's a GIS and geology student here at Mesa. He's working on this for a research project for the spring semester. He's digitized the 2000, and I have this noted as 2007-8. Most of the reach, we have a really high quality photo from 2008, and there's a little gap, and in that gap we are using a 2007 photo, and so we know which sections have been 2007. So he's the active channel bank line, and we're defining the active channel as the non-vegetated active channel, meaning that it gets flooded regularly enough that woody vegetation doesn't get established. So we have the 2008 bank line, and then in blue here is the 2012 bank line, and then he's created polygons that outline eroded area. And then what we're measuring is that the length of the eroded area, if we take that total eroded area divided by the length, then that gives us the average width of this eroded polygon. And then we're also measuring the maximum width of the eroded area. So our goal is then to, when we digitize the pre-removal sections, we'll be able to compare pre-removal channel changes with post-removal channel changes. So I'll just show you a couple of examples. He picked out 4 sites to highlight on his poster. Like I said, this is a work in progress. So site 3 here, this is the most dramatic one. The yellow polygon shows where Tamarisk removal was accomplished in, I have the date coming up here, 2006 and 7. It's by the Audubon Society in the use cut stump method. And the maximum distance across here is 68 meters of erosion in this cut bank. And then another, and here this is 1993. Here's that area right here, 2003, 2006, and then after 2011. So you can see that dramatic change where the river cut into the bank there. And then site 4 here, this is actually the site that sort of got this whole project going. The city of Grand Junction lost a chunk of their bike path, actually a couple of chunks of their bike path in 2011 right up here. And this is sort of highlighting the work in progress nature of this. Their Tamarisk removal at this site hasn't shown up yet in our database of removal polygons. So they actually did Tamarisk removal along the bank line here. And here the maximum width is about 34 meters of erosion. And just to give you an idea of what that looks like, here you can see the Tamarisk in 2007 and where the bike path is. And these photos are actually in the same place. The river has moved that much. So you can see that they lost the bike path here, and they had done Tamarisk removal all along this section of the river. And they also lost a chunk of bike path here, which had nothing to do with Tamarisk removal. So the dynamic nature of a river. So what we're doing right now, we're continuing the digitization of the aerial photos, starting to work on the earlier ones, refining our methods for how we're measuring the channel change, and how we're going to compare the pre and post erosion. We still have to complete the surveys of the riparian areas. And as part of the grant, we're also planning to do some bed material surveys as well. And in the future, we'd like to survey cross-sections on this island. Here, John Pitlick, a geomorphologist at University of Colorado Boulder, has an extensive network of cross-sections on this next island, which is also slated for removal next year. So we're hoping this summer that we can get out and get resurveyed John Pitlick's cross-sections, working with him, and then potentially resurvey all of them next time we have a near-bankfull or bankfull flow. So our future surveying is uncertain. It depends on snowpack. Actually, I'm hoping it won't be this year because then we have to redo our baseline. So thanks to the Tamarisk Coalition, CWC. So thanks to the Tamarisk Coalition, CWCB, and Xcel Energy for funding. Mesa County Surveyor's Office was just awesome with helping us out with all the GPS equipment. And the Tamarisk Coalition, Ben, all the work he did with the coverages, and then Colorado State Parks. Jeff Crane, he was our T-post pounder. And this is him fighting the Minka Shale, and Shannon Hatch and Alex for all of their work. So thank you.
I've actually got a couple if I can do them.
Sure.
One of them is, has anybody looked at, this is all on river channels, wetted portions, but where salt cedar has been removed from side drainages that maybe not the side drainage?
That's a really good question, and I have a study site in No Thoroughfare Wash, which is one of the ephemeral washes that drains the Colorado National Monument. And the Tamarisk Coalition, I know, is working on getting some funding to do removal in that wash, and we're hopefully going to be in there monitoring as they do that.
Visit with you after this.
Okay.
Before they get our